We can see people, buildings, and trees in the park. How do we see them? Unless they emit light, they must reflect light to be seen. When a beam of light hits a transparent medium, a portion of the light reflects off the surface, and a portion goes through the medium. The law of reflection states that for a smooth surface, the angle of the reflected rays is equal to the angle of the incident ray. Please note that all angles are measured from an imaginary line drawn at 90 degrees to the surface, called the normal. When a beam of light reflects off a smooth surface, it is called specular reflection. The word specular comes from the Latin word speculum, meaning mirror. Since the angle of reflection depends only on the incident angle, parallel incident rays will reflect at the same angle or direction. The reflections on a lake or the reflections you see in a bathroom mirror are typical examples of specular reflection. Unlike mirrors, most natural surfaces are rough. The law of reflection still applies here. But parallel incident rays hit the surface at different angles to each other, reflecting in many different directions. This is called diffuse reflection. And objects around us are visible thanks to diffuse reflections, reflected off those trees, buildings, and people. Light travels in all directions and enters your eyes. That's how we can see those objects. When a beam of light travels from one medium to another, it changes its direction or bends. This is called refraction. The law of refraction, also known as Snell's law, was discovered in 1621 by the Dutch astronomer and mathematician Willibord Snell. Snell's law predicts the angle of refraction as light travels from one medium to another. The angle of refraction depends on the incidence angle and the media that the light travels through, represented by an index of refraction. Why does light change direction when passing from one medium to another? Well, this is because light changes speed when going from one material to another. When light goes into a denser medium, such as from air to glass, for example, it slows down. The light ray is bent towards the normal. Conversely, when the light ray leaves the glass and enters the air, it speeds up and bends away from the normal. What happens if the light bends so much that the refracted angle becomes 90 degrees or even larger? In that case, no light will be able to travel out of the medium. There is no refraction. It is no refraction. Instead, it will be reflected back. And this is called total internal reflection. Fiber optic cables make good use of this property. Beams of light or data are reflected over and over without escaping and emerge at the end of the cable. Where do we find examples of refraction? In everyday life. Place a pencil in a cup of water. The pencil appears to bend at the water's surface. A rainbow is formed due to water droplets in the atmosphere. Water droplets split the white light from the sun into a beautiful rainbow. Lenses and magnifying glasses are typical examples of the refraction of light as well. Even our eyes depend on light refraction. Without refraction, we wouldn't be able to focus light onto our retina. Did you know that Isaac Newton was the first person to understand the rainbow? Yes, the famous scientist who was hit on the head by a falling apple and came up with the law of gravity. In the 1600s, Newton performed the famous experiment of shining sunlight through a prism from the window. Newton created a spectrum of colors on the opposite side of his room. This experiment showed that white light is actually made up of all the colors of the rainbow. Well, that's it for today.